Students, in this video, I'm going to explain to you the concept of a plumbing plan. When we talk about plumbing plan, it's a plan that's used to describe the plumbing of the house, specifically gas, cold water, sewer, and hot water. Okay. All of these utilities are typically underground. Every once in a while, you have some above ground or above roof line utilities. Some cases, gas sometimes runs in above the house in attics and things. But for the most part, in this one, everything's gonna be explained as an underground utility. Okay. So this is gonna be your final plumbing plan that I'm demonstrating to you right now. This is what it's gonna look like. I'll show you how to do that in AutoCAD in the next video. But nonetheless, this is all the plumbing that's gonna be in here. So there's gonna be two handouts. This is plumbing one, the handout that I'm giving you. On plumbing two is the second handout. This one describes how to draw the legal symbols, what they mean. And then it's kind of like uh, a zoomed in view of the plumbing. Okay. So I guess we'll start with the front. Here in this area, I'm going to be talking about this front area right in here, zoomed in a little bit for us. So we're going to start with the one on the left. Okay. So first things first, as far as from the house, where do we get our utilities from? Please understand that utilities come from the street. Down the street in front of your house, you have main lines of the different utilities. Which utilities? Gas, cold water, sewer, are the ones that come from as far as plumbing. Of course, we do have other utilities like telephone, cable. If now fiber optics is another utility that's coming down the line along the streets. So these are going to be tied in directly to the utility underground in front of your house, underneath the street. Kind of hard to believe that, but that's really the case. That you have a gas line. We'll start with the gas line. Is connected to the service line from the main street. So that's what this means, that the utility lines are from the main lines in the center of the street. Okay. And then this shows that it just continues. So the gas line continues all the way to the street. We're not going to show that on the plan. It's just to show that we are intending to connect that to that one. So we have a gas line coming in. So let me trace that. So we have our gas line coming in through here. This is the front wall of the house. Okay. And then it continues. So let me go to the next sheet and kind of trace that one carefully. So we have a gas line that comes in here and it's underground. And then you have the first legal symbol here, the little circle. Okay. The little circle, and I'll explain those here in a little bit, are just elbows that turn up out of the ground and up into within the walls. And then the gas line comes up out of the ground and into a pipe. And then that pipe is representing the first legal symbol here. That's called a gas valve. So the gas line is representing that we're wanting a gas valve at that location first. Okay. What is a gas valve? I'm sure you've seen one. Let me just go over to the internet. I had one here ready for you. It's a gas valve, just to show that we have a valve that we need to have in place to turn off gas whenever we have the furnace in the summer that you're not using. You turn off the gas as a safety. If you need to service the furnace and things like that, you just turn it off with at the valve. So that's what that little X stands for on the plumbing plan. So then from there, I had to kind of handwrite this one in because it wasn't there before. So I kind of handwrote it, but I'm going to add another gas line from here all the way across and over to the water heater. The water heater, we also want it to run with gas. It's more efficient. But as far as how it heats how it heats water, it's literally with a flame. It's a big flame that's underneath the water heater inside your house. So we need to run that with gas. Now, does it have to be gas? Not necessarily. There is such a thing as electric water heaters, which are less efficient, but they work just as well. But nonetheless, the gas is my preference, and that's what I'm asking in this case, to put in a gas line and a valve for one for the furnace and one for the water heater. We continue with the gas line. The gas line goes underground, and we're going to produce one here. It's going to come up out of the ground with this little elbow coming out of the ground to another pipe and a valve, another valve for our range oven. The range oven, I'm asking for that one to be also a gas appliance. There is such a thing as electric ranges. My preference is gas. I think it works better. It's also more efficient. But nonetheless, that's what I'm asking for as far as gas line. For the plan, that's really it for gas. Some side notes. On my house, in my house in particular, where I live now, I had the luxury of coming up with my own plan for different things because it was built by a home builder. But me being architecturally inclined, I asked, "Hey, can I do my own site plan? Can I do my own things?" And I did a plumbing plan, and I went ahead and added something like this. Now, why did I do something like that on my house? Why did I put a gas line and a valve outside to my house? Well, I like to watch football. I like to like I like to grill and cook hamburgers and steaks outside. So, how nice to have a gas line to hook up a barbecue to the outside of my house without having to worry about propane tanks, without having to worry about getting to I ran out of propane. I had to run down to Walmart and buy another tank of propane because I ran out of gas. Well, not me, the gas tank. Um, so I did that and I use it. I almost use that thing every freaking weekend. As a matter of fact, this past weekend I used it while watching some football outside. So it's modern conveniences, just things you can add to your house, makes your house your lifestyle a little bit more comfortable. It's neat and just a simple little thing as just adding another little gas line outside. I'm not going to ask for that here, but it's just food for thought for when you customize your own home in the future. Okay, cold water. Let's start with cold water. Let me change colors. And as far as cold water, same thing. Cold water continues from the front of the street. Just a little symbol is drawn like a little S. Let's trace the cold water. So the cold water underground comes up out of the ground over to a pipe to an HB. What is HB? Okay, what is an HB? HB is a hose bib. HB is a hose bib. What is a hose bib? It's a fancy term for this. I'm sure you've seen one before. You probably have one at home. It's where you hook up the hose, which is why they call it a hose bib. It's a weird word. It's not the valve. It's just the technical word. A term is a hose bib. Different variations, different sizes, and different styles of hose bibs, but essentially they all do the same thing. It's once again, so you can literally connect the hose to a water line, specifically cold water, at the front yard. The cold water line continues. We'll trace it right in here. Let me draw it with a line coming up in here. So that's cold water. It's going to come up out of the ground into our water heater closet, and it's going to connect to our hot water heater. Okay, so cold water is going to come in. Right now we'll trace it, but this is where hot water starts from. We have no hot water coming from the city. The hot water starts from your water heater. Let's continue with cold water. Before we go to the restroom area, let's kind of go up this way. Cold water, all the way through here. Okay. All right. And then from here, I really need to zoom in there a little bit better, but you'll be able to do this on your own a little later. It's gonna go over this way. Oh, I'm sorry, I traced the wrong one. Try not to not zoom in to make this video a little bit easier, but nonetheless. Cold water, cold water, cold water. Sorry about that. Coming up to this fitting coming out of the ground, and then cold water coming out this way. We're gonna provide cold water for the sink with a valve. And then we're going to continue this way with a hose bib for the backyard. Okay. We're going to continue adding water over here. We're going to add cold water for the dishwasher. We're going to continue this way. And then we're going to add cold water for the refrigerator. You might ask, why do we need cold water for the refrigerator? Well, some of these newer refrigerators, you might or might not have one at home. I know when I grew up, I didn't. Ice makers, and water dispensers in front of the refrigerator. So how does water get to the refrigerator? Well, there's actually a valve and a water line coming up to the location of the refrigerator. Okay. So that's our cold water for our kitchen area. Okay. So cold water goes this way underground, comes up out of the ground, comes this way, and we're going to provide a cold water valve for the lavatory. We're going to continue and provide a cold water valve for the water closet. Whenever you flush, the tank needs to get filled with water once again, cold water specifically. And then cold water for the tub, combination tub shower. Okay. I'm going to leave the cold water here and I'm going to come back and trace the hot water with a red line. So then the hot water coming out of the hot water heater is going to come up this way. Before I go to the restroom area, let's go up here to the kitchen. It's going to come up out of the ground. And then we're going to come and provide a hot water valve for the dishwasher. The dishwasher does need both hot water and cold water. And we're going to provide hot water for the sink. Okay. Now notice when you're facing the sink, which side is hot water and which side is cold water. The standard is hot is on the left, cold is always on the right. It happens every once in a while. You come up to a sink that you've never used before. You're like, oh, which one is the cold water, which is the hot water? If it's installed in the standard method, hot water is always on the left, cold water is always on the right. That is a standard method of construction. Hot water continues from here, comes up out of the ground. And then here we go again with providing hot water for the sink. Do we need to provide hot water for the water closet? No. The water closet runs on cold water. Your posterior does not need a steam bath, so you do not need hot water for the water closet. That's a joke, but that is true. You don't need hot water for the water closet. And then the hot water for the tub. Okay. So that's really pretty much it for hot water and cold water. Some things you can think about for the future if and when you get to design your own house. One thing I did at my house is I added where my grill is at. I added a cold water valve to the outside once again. So not only do I grill outside, I actually wash my hands outside, and I have a sink, and I'm able to wash a spatula or a fork that I'm using for steaks and stuff. So it's pretty neat. It's pretty neat. Okay. So again, I'm not asking that here, but it's just a few things that you can add for your own personal use in the future. Now, this is where I went wrong because that's where I stopped. What I should have done, and I didn't do that, I regret it, is I should have added also hot water to the outside too, and I didn't do that. I didn't do that. I forgot. I just didn't think about it, and not until Thanksgiving rolls around and it's cold outside, and I'm trying to smoke a turkey or fry it outside, and it's cold, and I'm washing my hands, and it's really, really cold. Well, that's when I remember I should have done this, Torres. You forgot. Yes, I did. I should have done that, and I didn't. So I have cold water outside, and that's how I freeze my hands when I'm smoking a turkey in the outdoors. But other than that, it's really not something that's needed. Okay, you don't really need hot water outside. It's just something that, or cold water outside. It's just something that you can add in the future. For this case, I don't really need it. Okay. The last part of the plumbing plan that we need to talk about is the sewer line. Okay. First of all, what is a sewer line? What does it carry? Gas is pretty self-explanatory. It's natural gas. It's what makes a flame burn on the range oven. Cold water. Well, I think we all drink cold water pretty much every day. What is sewer? Okay, sewer. Now, this is one of the things that I don't really talk about a whole lot. You've never really thought about it too much, and I'll have an explanation how it actually works. But as far as sewer is a sewer line. It carries solids. It carries liquids. It carries toilet paper. It carries unmentionable things. Okay, so that is a sewer line. The size of the sewer line, surprisingly enough, is not very big. The pipe of the sewer line is only about 4 inches in diameter. And you got to think about that. That's not a whole lot for all the stuff it actually carries. And I don't want to be disgusting about it, but it is a reality of the things that go in a sewer line. Okay, and I'm telling you right now, it's something that you use every single day. What you put in there, I really don't want to know. We all know what goes in a sewer line. So because of that, that's the first thing that comes up on a sewer line. So the first thing is, whoa, that's a big marker. Let me change that. Okay. So again, the sewer line, it continues, connects to the bottom of the street. So the first thing that we have on a sewer line, is a DCO. Okay. So the first thing you're gonna see on a sewer line is on the front of the house. It's what's called a double cleanout. It's a double cleanout. What is a double cleanout? Okay, well, I have a picture of that here for you. A double cleanout, you probably have seen it. It's the only part you're going to see on the surface is really just this little cap. It's like a little white cap with a little square on it, I guess. Okay, so this is really the only thing you're going to see on the surface. But if you were to ever take that off, what it is, it's a double clean out. So what this is on the surface is, in case there's something that gets stuck on the sewer line, those things get stuck on sewer lines. Yes, they do. Yes, they do. And it doesn't have to be the unmentionables. It could be a dish rag. It could be your little brother or little sister flushed a teddy bear down the toilet and it got stuck on the sewer line. It happens, ladies and gentlemen. It really does. So then, if it gets stuck, then you can't use the sewer line. You can't flush the toilet. You can't use the sinks. You can't use a shower. Somebody has to go out there and clean it. So usually call the plumber. The plumber will take off this little cap, and then what they'll do is they'll stick what's called a sewer snake. It's just a big long cable that goes in there and literally runs through there. And yes, it cleans out and it comes out nasty and black and smelly. But again, a very necessary thing. But to be able to clean it in both directions, that's why we're asking for a double cleanout. Because if you can kind of see the this fitting here will aim the cable towards one side only. So that's why we're asking for a double cleanout, because that way you can clean it in one direction or you can clean it in the other direction. Where is that little teddy bear stuck in the sewer line? We don't know. So they have to go and look for it, and they go in there and clean it out, and a very, very messy, disgusting process. I hate to say that. I've done it before in my house when I was growing up, because my mom didn't want to hire a plumber. So I've done it before. Not the nicest thing in the world, ladies and gentlemen. I'll tell you right now. But again, that's what it is. A double clean out is so that we can clean the sewer line. It is underground, to clear out any type of clog that might have occurred. Okay. So that's the first thing we have on the sewer line, usually in the front of the house. Okay. So the sewer line continues into the home. Let's go right in here. Let me keep tracing it with some line work. Goes this way. And then the sewer comes up in this direction. I'm trying to trace it as nicely as I can. Let's go to the kitchen area. One other thing to notice on sewer lines, notice the bends on sewer lines. The magic angle on a sewer line is 45 degrees. You never want to have a sewer line coming out at a 90-degree angle. You never want that. And I'll explain why that is on my next explanation, because this has more of a tendency of clogging. 45 degrees runs a lot smoother. 90-degree sewer lines is just a no-no. You don't do that. It's just something you don't do. Okay. So let me continue with the explanation. We're going to come up with a sewer line. It's going to connect to the garbage disposal in the kitchen. And then the secondary, since this is a double sink, going to continue at a 45-degree angle. We are going to provide a drain for the dishwasher. So the dishwasher, when it washes the plates, uses hot water and cold water. Once it's done with the dirty water, it needs to pump it back out into the sewer system and out into the sewer system on the front of the street. Now, this is another one that comes up here, is we need to provide this little circle on the sewer line. Okay, so before I get to this, which is a cleanup, by the way, let me explain what that is. That little circle inside the wall is what's called a vent. Okay, that's what's called a vent. All right, so what is a vent? What happens with sewer, ladies and gentlemen, is that sewer lines need to have a vent system. Okay, they need to have a vent system. Let me go right in here. So what happens with a vent system is that you have sinks that are connected to the sewer line, toilets, laundry room, there's the sinks and things like that. But the thing is, they actually need to have air. The sewer line needs to have air. So all of these are connected to a vent stack that actually pops out into the roof. And I'm sure you've seen them. I'm sure you've seen them. You've seen them outside on the roof, on your roof. If not, go out there and look, and you'll see them. You'll see these little pipes sticking out of the roof. Okay, and you're probably wondering, why do we need a pipe sticking out of the roof that's specifically for sewer? Well, how does sewer actually work? I mean, like, I don't know if you ever thought about that. When you flush the toilet, when you use the sink, where does the water go? Oh, well, it just goes down the toilet, but where? Okay. One of our guest speakers talked about that. She works with water and wastewater, so we're talking about wastewater in this case. Where does it go? Well, she mentioned it goes to a wastewater treatment plant. Where is the wastewater treatment plant? It's not next door to your house. It's way down the street, probably on the other side of town. So how does sewer actually get there? It's kind of strange, but it actually just goes by gravity. That's all it is. It's just simple gravity. Okay. There is no special pumps. There's nothing to suck the sewage out of your house and send it all the way to the water treatment plant. Like here at the Riverside area, we're actually pretty close to a water treatment plant, but it's over there by the Chamizal, which is still a good drive from here. So when I go to the restroom here at the school, and or you go to the restroom here at Riverside and flush the toilet, it goes down through pipes and then underground and up to the river to Midway and down Alameda and through Alameda down to the border highway. Yeah, that's where the wastewater travels. And how does it travel? Literally by gravity. It's just going downhill on a pipe system. Okay. A system invented, from what I understand, I think it was the ancient Romans or the Egyptians. It's gravity flow, and it's still something we use today. That is absolutely crazy on how that works. Again, there is no special pumps or machines that suck the sewage out of the house. It's literally just gravity. That's it. Okay. So then for the gravity flow to work, it needs to have air. It's almost like the same concept. And I don't have a straw with me, but you guys have done this when you're at the McDonald's or Whataburger with your friends, and you're drinking out of the cup, and sometimes you put your finger on the straw and you pick up the straw, and you have the soda in there, and then you take off your finger from the straw, and all of a sudden the soda drops. Boop. Same concept. The sewer line needs to flow. If you're covering it and we didn't have sewer vents, all that sewage would be stuck and it wouldn't go anywhere. Not until you let the straw go, and then air gets to the back of the straw, and whoop, all that goes away. You got to make sure you do the sound effect, because otherwise it won't work. Whoop. All right. And so sewer lines. So that's how that works. It's a system that we're used nowadays. It's a very ancient type of system, but it's being used now. A little bit more sophisticated with closed pipes. And the pipes that run the main sewer lines that run on Alameda and Midway, and the ones collecting sewage from neighborhoods and areas, big industrial areas, those pipes aren't very big. The biggest sewer line I've ever seen is only about 12 inches. And every once in a while, you have a 16-inch pipe. And that carries not only your sewage, your next door neighbors, your front door neighbors, then the one next to them, the one next to them, and probably about several thousands of people using that one 12-inch sewer pipe. Crazy. But that's how sewer works. Okay. Yeah, it's not a very nice thing to talk about, but guess what? That is civil engineering, ladies and gentlemen. Sewer systems, water systems are actually civil engineering, and that's a specialty. Just like Nancy mentioned, that's all she specializes in. And you can kind of see, because they have to calculate slopes and how much it carries. They need to talk about peak flows. When do you use a sewer line the most? Usually, sewers are used mostly between 6 and 9 a.m. in the mornings. What's happening during those times? You're taking a shower, you're brushing your teeth, your little brother's using the toilet, getting ready for the day. The other peak time is usually, I think it's between 7 and 10 p.m. What's happening in that time? You're getting ready for bed, you're brushing your teeth once again, hopefully, using the toilet, taking a shower. So those are the peak times in the evening. So those are all things that engineers have to calculate to make sure that the sewer system can handle that type of capacity. Once again, civil engineering. I mentioned at the guest with the guest speaker that civil engineering is one of the unappreciated disciplines, because you don't really talk about sewer. You don't really talk about all that, because who wants to talk about that? Well, if that didn't happen, guess what? You wouldn't be able to flush the toilet at your house. You wouldn't be able to as to brush your teeth in the sink and just not worry about it. Um, how did people live without sewers? Yeah, you can just imagine how that would be. Okay, so again, just a very unappreciated thing as far as civil engineering. Okay, so we have a vent pipe. The vent pipe is connected to the sewer line. We kind of go in here. This is the drain for the dishwasher. Sewer line comes into the vent pipe. And then we have a clean out over here at the back. We have a clean out, okay? So this clean out is a little bit different in that this is a wall clean out. And I didn't Google that. I should have Googled that. Sorry about that. But let's go look for a sewer, not a vent, sewer wall clean out. So that one is not necessarily going to be on the ground. It's going to be on the wall. And you've seen them. Sometimes it's kind of like on the wall like this, or this is kind of messy because it really should have a, it shouldn't be exposed like that. But I'm looking for, there we go. I think these are the ones that you've seen mostly, and you might have seen them in restrooms. And on the wall, oh, that was an ugly one. On the wall, you just see this shiny disc, and what that is, it's a clean out. It's where the plumber will go take that off and be able to stick the sewer snake in there and clean out the sewer line, kind of like what this guy's doing. So he goes in there and, oh, this guy's using a sophisticated camera system. That's pretty neat. Again, technology is really awesome because sometimes they use these camera systems to find the clogs inside the sewer line. Because, like I said, I mentioned there's a teddy bear in there. Where is it? We don't know. Some of these plumbers run around with these little fiber optic cameras. They can put it down the sewer line and look for error things that went wrong in that sewer system. Okay. What kind of things can go wrong with sewer systems? Trees, all kinds of things can happen in the sewer systems. But nonetheless, I wasn't expecting to see this picture, but that's a good one. Okay. All right. Okay, let me trace the sewer line. We talked about the kitchen already. Let's go into the restroom areas. So we have a vent pipe. Here it is. This is the one that sticks out of the roof, and it connects to the sink. And I mentioned it earlier, since it's all gravity flow, sewer lines are at a 45-degree angle. So all these connections need to be at a 45-degree angle because, again, there isn't a special machine or nothing. It's just literally gravity, and it just needs to flow. So it's very hard to flow sewer at a 90-degree angle. So that's why you don't want to do that. It's usually at a 45-degree angle. So that way everything can flow. Yes, all the unmentionables can flow nicely at a 45-degree angle. So these are all going to be 45s. So we have the sink. We have another sewer line coming up to another vent pipe to the water closet. And then we have another sewer line into the tub. Okay. And then once again, not a bad idea, but to add another clean out at the end of this line. We don't have to do that, but these are the things that make it nicer, because if we didn't have this clean out, and it does happen every once in a while, how could they clean a clog that could have potentially happened somewhere in here? Let's say there's a clog in here, and you don't have a clean out back here. What do they have to do? They have to sometimes go through the water closet, and they go in there and with that cable system in the restroom, and they put it in here, and black stuff comes out and it gets all on the floor and starts smelling in there, and the plumber is all sweaty, and it's just little things that can make your life a lot easier. That way the sweaty plumber can go in the backyard. No offense to our plumbers, but it is a hard job. As then you can go in the backyard and work on the clean out from the back and not have to worry about having to work inside the restroom. Or if you're a DIYer, do it yourself, this, ladies and gentlemen, will be a lot easier for you. Trust me. I've done it before with my two hands. Not a very luxurious thing to do. Okay. That is a quick explanation on sewer lines. Right now, when we talk about the AutoCAD and how to draw it, I'll show you how these symbols are used and what size to draw these. But these are all the symbols that we're going to be using, the size of the diameters of the circles for water closets and things. So I'll explain that on our next video.